So here's a little tougher question. We're going to have to kind of unwind what we've learned today. We're going to write the equation of a possible rational function, meaning that there's many possible answers, with the following characteristics. Okay, it's going to have a vertical asymptote at x equals -4, a point of discontinuity at -11/2 and 9, and an x-intercept at 8. Whew. You ready for this? Yay! So, I'm going to deal with each of these pieces one at a time, and I'll color code them. I'll do this part in blue, I'll do this part in green, I'll do this part in red. Okay, so let's deal with the vertical asymptote at x equals -4. Okay, let's deal with that first. So we start with just a base function, f of x equals 1/x. How could I give that base function a vertical asymptote at -4?
X plus 4.
Yeah, put x plus, make -4 a non-permissible value. Does that make sense? So this would become f of x equals 1/x plus 4. So far I have a function where there is a vertical asymptote at -4 because I've made -4 a non-permissible value and it doesn't cancel with anything at the top. Good? Okay. I'm going to do the red next because that's a little easier. How would you create an x-intercept of 8?
X minus 8 in the numerator.
Yeah, put x minus 8 in the numerator. Okay, so let's do that. Let's do x-intercept at x equals 8. And the way we do that is we take what we had before, and we put x minus 8 up top. Why does that create an x-intercept at 8?
Because it shifts it over units, right? For translation.
That's a nice way of putting it. Okay. Sure, it shifts it over 8 units, right? Also, if you think about it, if you put in 8 here, maybe just do it for a second, right, so you can see how it works. If you put in 8 up top, and then went minus 8 over 8 plus 4, that gives you 0 over 12, which is 0, right? So you're getting a y value of 0, and that's where it crosses the x-axis. So this is what we have so far, right here. Okay, so we got the asymptote, we got the x-intercept. Now the hard one, the point of discontinuity at -11/2 and 9.
How do you get 9?
How do you do that?
Like the 11/2, you would just do x plus 11/2 in the numerator and denominator, right? Do they cancel out?
Do you have to worry about the 9?
I was thinking about that too. I tried this beforehand. You don't have to worry about the 9, which is really nice. I'm not exactly sure why. It does work out so that doing what you said makes the point of discontinuity occur at a -11/2. And for some reason it works out that 9 happens to be the y value at that point.
So it's not that you have to find the 9.
So you don't have to worry about messing around with your equation so that the y value matches. You just have to make sure that you have the point of discontinuity where you want it to be, and it'll fit into the graph where it needs to be.
How would you do that if you were messing?
Yeah, weird, eh? Take a look at it in a second. So we've got, so far, we've got f of x equals, what was it, x minus 8 over x plus 4. And we want x, this is our point of discontinuity, to not equal -11/2. Right? It is a non-permissible value that got cancelled. So just like we did with the vertical asymptote, I'm going to rewrite it in a factorial form. So I'm just going to equate it to 0. So this would be 2x doesn't equal -11, and then bring over the 11. 2x plus 11 does not equal 0. So this would be the factor that I would put in the top and the bottom. You could, let me put it this way. You could also put x plus 11 over 2.
That's how I thought of it.
You could put that. You want to do that instead?
So yeah.
Yeah? You understand why this means that x can't equal negative. Maybe I'll put it in the equation so you can see.
Yeah.
So if I put that in the equation, I would just multiply it by what's already there, right? So I want it in the bottom. I want x plus 11 over 2 in the bottom, right? Because I want x to not equal negative 11 over 2. So that right there guarantees that. If I put it in the top as well, that changes it to a point of discontinuity. You understand that? Okay, so I'll just leave it at that then. This also works though, because this is just an algebraic manipulation of this, right? So that would look like this. So we took x cannot equal negative 11 over 2, and we brought it over, right? So that's how you guys got yours, right? If you multiplied everything by 2, you have the same thing essentially, right? So you could do either one. Does that make sense? Good. Okay, you guys want to do another one, or
Yes.
you want to do another one?
Yes.
Okay, so let's do another one. We start out with just plain old f of x. I'm gonna do the vertical asymptote first. So start out with
1 over x minus 3.
just 1 over x, right? And if I want a vertical asymptote at 3, you put x minus 3, right? You make 3 a non-permissible value, and you make it so that it can't be cancelled, which we have so far. Okay, let's do the blue next, the x-intercept of negative 1. So how would I do that? Something I do to the top. You could start with a x-intercept of 0, and then I want to move it 1 to the left. So how would you do that?
X plus 1.
X plus 1, right? Does that work? X plus 1, yes. And if you put in negative 1 here, that makes the whole top 0, making the entire thing 0, so that still works. Still with me? Now the point of discontinuity. So we've got x plus 1 over x minus 3, and I want the point of discontinuity to occur at negative 2. So how would you do that? How do you first make it a non-permissible value? Similar to what you did with the vertical asymptote.
So it has to be x plus 2 then.
Yeah, you want the factor x plus 2 in the denominator, right? That will make it a non-permissible value. So let's do that. So x plus 2. So it's a non-permissible value, and the way it is right now, it's an asymptote. But to change it to a whole, what would you do?
X plus 2 on the top.
X plus 2 on the top as well.
That's it.
That's it. Okay, got it?